Okay, well, welcome everyone. Thank you for joining. I hope you're all excited to do some GMAT quantitative reasoning exercises with me. This workshop is going to be focusing on topics divisibility, multiples factors, number properties, arithmetic, and algebra. I'm going to talk a bit about me and why I think you should be listening to how I approach these problems. In regards to the GMAT, I have more than 5 years of experience coaching. I was a GMAT director at this institute that sold GMAT and admission services. I was sourcing, hiring, and leading the GMAT department. Currently, I am a full-time coach offering GMAT and admission services, soon to offer other services as well. On Leland, I have more than 25 five-star reviews. I recently completed my MBA at Booth, where I was admitted with a merit-based scholarship. I was selected as Argentina country captain. I was working with Booth's admissions committees, so I'm pretty good at admissions consulting. During my MBA, I interned at BCG, received various consulting offers. So also if you need any help or tips regarding consulting or breaking into consulting, more than happy to. So let's talk a bit about this event. As mentioned before, we're going to be doing QR exercises regarding divisibility, multiples and factors, number properties, arithmetic, and algebra. You'll be given 3 to 5 minutes to do each exercise, and then I will explain how to do the exercise step by step. I would ask everyone please to mute your microphones. If you have any questions regarding an exercise and or solution, take note of the question ID and send me a message via Leland. You have a QR code on the bottom left that gives you directly to my profile. All right, let's start. The question is on the left-hand side. You have 3.5 minutes. Okay, time is up. I hope you had time to finish the exercise, but if not, that's fine. Just sit back and absorb this explanation. If we treat the answer choices as x, essentially what we're looking for is 84 times 108 divided by x is not an integer. That's what we're looking at. So we're translating English into math. So a great way to do this without a calculator is to understand what 84 and 108 are made of. And we do that through prime factorization. So 84 is essentially 4 times 21. 4 is 2 times 2. And 21 is 3 times 7. So when we prime factorize 84, what we have is 2 squared times 3 times 7. Now we're going to do the same process for 108. 108 is 4 times 27. 4 is once again 2 times 2. And 27 is 3 times 9. And 9 is 3 squared. So what we have is 108 is equal to 2 squared times 3 cubed. Considering that we're looking for an x that makes 84 times 108 not an integer, we want to view, once again, the prime factorization. So we have 2 squared times 3 times 7 times 2 squared times 3 cubed, which gives us 2 to the 4th times 3 to the 4th times 7. So in order for this fraction to not be an integer, x must contain something other than 2 to the 4th times 3 to the 4th times 7, because that way the numerator cannot cancel out the denominator and thus will not be an integer. What we are going to do now is look at each answer choice and ask ourselves, is the fraction an integer or not? So in A, we have x equals 36. 36 is 6 times 6. 6 is 2 times 3. And obviously, once again, 6 is 2 times 3. Therefore, 36 is 2 squared times 3 squared. Now, when we input this prime factorization for x, we have 2 to the 4th times 3 to the 4th times 7 divided by 2 squared times 3 squared. And this gives us 2 squared times 3 squared times 7. And therefore, this is an integer and not the correct answer choice. We eliminate it. B, x equals 42. 42 is 2 times 21. 2 times 21 is actually 2 times 3 times 7. Apologies for that. And this will give us an integer, and therefore this is an incorrect answer choice. C, x equals 63. 63 is 3 times 21. And 21 is 3 times 7. So 63 gives us 3 squared times 7. We input this into the fraction. And this gives us, once again, an integer. We have 2 to the 4th times 3 squared. We eliminate this answer choice. D, x equals 96. 96 is 4 times 24. 4 is 2 squared. And 24 is 4 times 6. 4 is once again 2 squared. And 6 is 2 times 3. So 96 is 2 to the 5th times 3. And in this case, what we have is a fraction that is 3 cubed times 7 over 2. And this is not an integer, and therefore this is the correct answer choice. So when we're trying to approach these types of problems, we want to be very organized, visualize the exercise, and test each answer choice to get to the correct answer. Great. All right, let's do this exercise. You have 4 minutes. All right, time is up. If you had a chance to finish the exercise, great. If not, please stop what you're doing and absorb this explanation. And please, everyone mute your microphones. Thank you. So what we have is basically an integer z that must be greater than 6. And we're asking which one of these answer choices has 3 as a factor. So essentially what we're being asked is which one of these answer choices, when divided by 3, equals an integer. Now, if we look at the answer choices and we see it as w times x times y, we will be able to understand that if one or more of these integers, w, x, and or y, is divisible by 3, then the product of w times x times y will also be divisible by 3. So knowing this, what we can do now is input values for z and test each answer choice and eliminate incorrect answer choices through a process of elimination. For example, if z equals 7, then a becomes 7 times 6 times 9. And we can see that the 9 is divisible by 3, and therefore this answer choice is possibly correct. Now, when you input values for variables into the answer choices, you can get false positives, which are true for certain values of z, but the real correct answer choice will be true for any value of z. So it's extremely important to eliminate 4 answer choices before selecting the correct answer choice. So A is possibly correct. B, if z is 7, then we have 7 times 5 times 11. And in this case, no number within this product is divisible by 3. And therefore, we can eliminate answer choice B. C becomes 7 times 3 times 8. 3 is divisible by 3. So this answer choice is possibly correct. D becomes 7 times 2 times 10. And in this case, no number is divisible by 3. So we can eliminate this answer choice. E becomes 7 times 1 times 12. 12 is divisible by 3. So this answer choice is possibly correct. Now, when z equals 7, we were able to eliminate answer choices B and D. So what we will do now is choose another value for z, testing the remaining answer choices. If we say that z is equal to 8, then A becomes 8 times 7 times 10. And in this case, no number is divisible by 3, and therefore we can eliminate answer choice A. C. If z is equal to 8, c becomes 8 times 4 times 9. And in this case, 9 is divisible by 3. So this answer choice is possibly correct. E. E becomes, when z is equal to 8, 8 times 2 times 13. And in this case, no number is divisible by 3, and therefore we can eliminate answer choice E. Thus, after process of elimination, the correct answer choice is C. Now, what I really want you to get from this explanation is that on the GMAT, you can use answer choices to your benefit. Know that you don't have to make up the correct answer. The correct answer is right in front of you. And you want to think of ways to make your life easy. And that's why inputting values for the variables can be very beneficial. And being organized when you do that will allow you to really increase the probability of you getting it correct in under 2 minutes. Great. Let's go on to the next exercise. The questions on the left-hand side, you have 4 minutes. All right, time is up. Hope you had enough time to attempt the problem. If not, that's totally fine. Let's just sit back and absorb this explanation, right? It's sometimes very possible that you will get a bit confused of how the GMAT words certain questions, how they phrase it. It might be intimidating. So it's important to break complex problems into small, manageable components and really try to visualize what's going on. So we have 100 is greater than or equal to z, which is greater than or equal to 4. We also know that 1/4 z is equal to a prime squared. Now, to make our lives easier, we could isolate z by saying z is equal to 4 times prime squared. We could then input this into the inequality because we now know the value of z. So we have 100 is greater than or equal to 4 times a prime squared, greater than or equal to 4. Now, given that each number is positive, I can manipulate the inequality by dividing everything by 4. So what we have is 25 is greater than or equal to a prime squared, which is greater than or equal to 1. And we can further simplify the inequality by doing the square root for each particular side. And we are left with 5 is greater than or equal to a prime, which must be greater than or equal to 1. And we have a couple of primes that satisfy this. The first prime is 5. The next prime is 3. And the last prime is 2. So we have in total 3 prime numbers that satisfy this inequality. And so our answer is 3. So when you go into complex GMAT questions, don't think, what do I not know? Think about what you do know and start working from there. Break complex problems into small, manageable pieces. Great. Let's go on to the next exercise. You have 3.5 minutes. Okay, time is up. Let's see how we can do this exercise. So this particular exercise has a lot of content. It's really important to try to visualize what's going on, basically translating English into math. So essentially what we have is phrasing or citing the question, the product of the weight values of each removed coin is 441,000 grams. Essentially, 441,000 must be equal to the amount of Turkey times Rome times Mexican times Greek coins, right? And the exponents A, B, C, and D represents the amount of Turkish, Roman, Mexican, and Greek coins, respectively. Since we're being asked how many coins from Rome were removed, we want to look at the exponent for 3, because that is the weight value of Roman coins. So we are being asked B equals what? And this is a way in which we can translate English into math. The way we can see the prime factorization is doing what we did in the first 2 exercises, just being organized and disciplined. 441,000 is equal to 441 times 1,000. 441 is equal to 21 times 21. 21 is equal to 3 times 7. 21 is equal to 3 times 7. 1,000 is equal to 10 times 100. 10 is equal to 2 times 5. And 100 is equal to 2 squared times 5 squared. So 441,000 is equal to 2 cubed times 3 squared times 5 times 7 squared. So we know, thus, 2 Roman coins must have been removed. On the quant section of the GMAT, the math is not hard. What is hard is understanding the math you have to do. So that's why it's extremely important to get accustomed to how the GMAT phrases certain types of questions and really try to understand what you're being asked to do. That is the difficult part of the GMAT. Then execution of what you must do is rarely difficult. Great. Let's go on to the next exercise. You have 3.5 minutes. All right, time is up. Let's see how we can approach this exercise. So we're being asked the ratio of 21/9 to 3.875 is approximately which one of these answer choices? We can visualize this in the following manner. 21/9 to 3.75 is equivalent to 21/9 divided by 3.75. So this is the question being asked. Now, we don't have a calculator for the quantitative reasoning portion of the GMAT. So we have to be extremely efficient and think of an intelligent way of how to approach this number. Essentially, 3.75 is equal to 3 plus 1 minus 0.125. 0.125 is 1/2 of 0.25. Now, when we're dealing with decimals on the QR section of the GMAT, it's easier to work with fractions. So we could essentially say that 0.125 is 1/2 of 1/4, therefore 1/8. So what we have is 3 plus 1 minus 1/8. Therefore, we have 3 plus 7/8, which gives us, once again, in fraction form, 3 is 24/8 plus 7/8. This gives us 31/8. So the fraction form of 3.75 is 31/8. So we can visualize the question as, what is 21/9 divided by 31/8? This is equivalent to 21/9 times 8/31. We pass the division by flipping the fraction, and we multiply. Now, we want to see what these numbers are made of. We want to prime factorize. It's a great tool to do these operations without a calculator in a fast way. So we have 3 times 7 over 3 squared times 2 cubed over 31. This way, we can easily cancel out the 3 on top and bottom for the first fraction, and we have 7 over 3 times 2 cubed over 31. This gives us 56/93. Now, when we look at the question, it's asking us approximately. Therefore, we could round in an intelligent manner this fraction so that our division is more simple. So this is approximately 54/90. And this is equivalent to 9 times 6 divided by 9 times 10. We cancel out the 9 on top and bottom, and we're left with 6/10, which is approximately 0.6. That is our answer, D. Now, initially, it might be a bit tempting to round 3.75 to 4, given the question's asking approximately. But given how close each answer choice is to one another, if you round 3.875 to 4, it's going to influence the fraction value too much. And therefore, you can easily get a wrong answer choice. Great. Let's go on to the next exercise. You have 4.5 minutes. Okay, time is up. I recognize that this problem is a bit more difficult than the previous ones we were doing, but I still want you to attempt this. That's the point, just getting better through trying. Let's see how we can approach this. So I want to go into this problem not thinking about what I don't know. I want to work with what I do know and see where it leads me. So I know that what I'm looking for is the 10,000th, sorry, I'm not pronouncing that correctly, digit. And that is essentially right here. And we know that the fraction 2 over 27 to the fourth is equal to some number, right? And of course, we're looking for this digit right here. Now we can distribute the exponent to the top and bottom. So we have 2 to the fourth over 27 to the fourth. Now, we don't have a calculator on the QR section. So there must be a simple, elegant way to approach this problem and solve it efficiently in under 2 minutes. So I look at the answer choices and I see A, 0. And I start thinking, okay, given that the GMAT knows I don't have a calculator and the GMAT expects me to do this in under 2 minutes, there might be something there. So what I do know is that 1 over 10 to the fourth is equal to 0.0001. So with that in mind, if the fraction that we call x is less than 1 over 10 to the fourth, that means that x is less than 0.0001. And if x is less than that value, that means that this digit will be 0. So if we can conclude that this fraction is less than 1 over 10 to the fourth, the answer would be 0. So that's the question we're asking ourselves. Is 2 to the fourth over 27 to the fourth less than 1 over 10 to the fourth? All right, now we're also thinking, how can we prove that? How could we even ascertain that without a calculator? Don't think about what you can't do. Think about what you can do. So what I can do, for example, is approximate 27 to the fourth to 20 to the fourth. That is a calculation that's much more manageable. 20 to the fourth, once again, is easier to calculate and will be a multiple of 10. And so it will be easier to compare with 10 to the fourth. Now, given that 27 to the fourth is greater than 20 to the fourth, I know that the fraction 2 to the fourth over 27 to the fourth will be less than 2 to the fourth over 20 to the fourth. Great. Now, what do we do? Well, we keep on thinking about what we do know. We know that 20 to the fourth is equivalent to 2 times 10 to the fourth. And I can distribute the fourth to each term, and I have 2 to the fourth times 10 to the fourth is equal to 20 to the fourth. And you see that we have a 2 to the fourth on top and on bottom of this fraction. We can cancel that out, right? And what we see is 1 over 10 to the fourth. So 2 to the fourth over 20 to the fourth is equal to 1 over 10 to the fourth. And therefore, we know that 2 to the fourth over 27 to the fourth is less than 1 over 10 to the fourth. Therefore, the digit will be 0. And a question you could be asking yourselves is, well, how will this come to me on the test? That comes with practice. by understanding the underlying logic of the GMAT, not approaching the QR section with a mathematical mindset, but as a logical test, understanding the reasoning that they're asking you to apply. Now, you could also be asking, what if A wasn't zero? What if zero was not an answer choice? Then this problem probably will not appear on the GMAT because they want to test if this type of reasoning will come to you on the test. So I would bet that if you have a question like this, zero will be one of the answer choices. Okay, let's go on to the next exercise. You have 4.5 minutes. All right, time is up. I hope you all had a good time attempting to solve the problem or have solved the problem. Let's see how we can approach this exercise. Now, it's very easy to get intimidated by these types of questions because honestly, functions is just saying, this is how it is. And you have to be willing to accept that. There's no logical reason as to why k pound is equal to k over k minus 2. But that's not our job. Our job is not to think why this is the case. It's just to accept that and see what you can do to solve the problem they're asking you. I know that sounds a bit abstract, but it's important to visualize what's going on. So let's break this down into simpler components. What we are going to do is we are going to use a smart valid value for z. And a valid value for z is basically respecting the fact that z cannot equal 2. And then we're going to calculate z pound, then calculate z pound pound. And our final step would be to use process of elimination to eliminate 4 answer choices. Let's start. So z pound is equal to z over z minus 2. Great. Let's say z equals 5. So 5 pound is equal to 5 over 5 minus 2, which is 5/3. Great. Now we do the exact same thing. 5/3 pound is equal to 5/3 over 5/3 minus 2. 2 is equal to 6 over 3. And we have 5/3 divided by negative 1/3. Now this is equivalent to 5/3 times, flipping the fraction, minus 3. This gives us minus 5. So essentially, when z equals 5, z pound pound equals minus 5. Okay, Josh, now what do we do? Well, we're going to put this into the answer choices. We're going to test them out. So when z equals 5, a, which is 1 over z, becomes 1/5. Now 1/5 is not equal to minus 5. Therefore, we can eliminate answer choice A. Let's look at B. B is minus z. So z is equal to 5. Therefore, minus z is minus 5. And therefore, this is a possibly correct answer choice. So we cannot eliminate it, but we cannot say it's the correct answer choice yet. C. C is z. Well, z is 5. And 5 is not equal to minus 5. So we can eliminate answer choice C. D, which is z over z plus 2. We have 5 divided by 5 plus 2, which gives us 5 over 7. And this is not equal to minus 5. So we can eliminate answer choice D. E. E is z divided by minus z plus 4. So we have 5 divided by minus 5 plus 4, which gives us 5 divided by minus 1. And this is minus 5, which is, of course, equal to minus 5. So this is possibly correct. So when z equals 5, we were able to eliminate A, C, and D. Now we're going to choose another smart valid value for z. And we can say that z is equal to 7. So 7 pound is equal to 7 over 5. 7 over 5 pound is equal to 7 over 5 divided by 7 over 5 minus 2, which gives us 7 over 5 divided by minus 3/5. which is equivalent to 7 over 5 times minus 5 over 3, which gives us minus 7 over 3. So when z equals 7, z pound pound is equal to minus 7 over 3. So we want to test out the two answer choices that are left, B and E. B, when z equals 7, minus z becomes minus 7, which is not equal to minus 7/3. So we were able to eliminate B. So we do know that E must be correct because we were able to eliminate 4 answer choices. But just to triple check, if you want, you can input 7 into E, and you have 7 divided by minus 7 plus 4, which is, of course, equal to minus 7/3. And so E is the correct answer choice after process of elimination. And this always goes back to how I like to approach GMAT, which is, how do I make my life easy? I know that sounds a bit cliche, maybe, or very vague or general, but if you decide to work with me on the GMAT prep, you're going to learn a lot of strategies, tools, and mindsets to approach the different sections of the GMAT. And these types of approach will come to you when your purpose is not to do math, but to make your life easy. All right, let's go on to the next exercise. You have 4 minutes. All right, time is up. Let's see how we can approach this exercise. So we know that k to the fourth plus w to the sixth equals 102,400. And we're being asked the greatest possible value for k, or k max. Now, to maximize k to the fourth, and therefore k max, we want to minimize the value of w to the sixth. And the minimum value w to the sixth can take is 0. So essentially, k4 max is 102,400. Now, you might be tempted to prime factorize, which isn't a bad thing necessarily, but in this particular case, will not be the most optimal way of approaching this problem. On the GMAT, you have 5 answer choices. So you don't have to calculate the greatest possible value of k. You just have to choose in which range it's located in. So let's keep that in mind, right? And what we have essentially is this table of min k and max k, depending on the answer choices. Now, if we were to elevate this to the fourth power, we would have these values right here. Now, these values that we see on the table are also difficult to calculate without a calculator, and especially in under 2 minutes, which is the time constraint for the QR section. So you want to think about what you can do without a calculator and how you can optimally approach this particular problem. And so I want to find k4 max is within which of these ranges. Now, I want to start with answer choice C because it is the mid value. It is the median. So let's look at min C. Min C is actually 25 to the fourth, which is a difficult number to calculate. But we know that 25th to the fourth is greater than 20 to the fourth. And 20 to the fourth is an easier number to calculate without a calculator. 20 to the fourth is 20 squared times 20 squared, which is 400 times 400, or 1600 times 100, 160,000. So the minimum value in C range is greater than 160,000. And therefore, we can eliminate C. Because K4 max must be below 160,000. And the reason why I wanted to start with C is because if the min value of C is 160,000 plus, that means that every other value above that is also above 160,000. So I can eliminate C, D, and E. Great. Now let's continue. Let's look at A. I want to look at the max value for A, because if the max value for A is less than K4 max, then we can eliminate the answer choice. Now, the max value for K4 and A is 15 to the fourth, which is 15 squared times 15 squared, which is 225 times 225, which also seems like a difficult number to calculate. But I know it's less than 250 times 250. And this is the same as 2,500 times 25, which I know must be less than 100,000. So given that the max value for A is less than 100,000, that means that K4 max is above that range. So after process of elimination, we know that B is the correct answer choice. So this, in my opinion, is a more efficient way of approaching this problem than prime factorization. And you see that we solved it in a similar manner as in a previous exercise that was seemingly different, but could be answered in a similar fashion. That's how you should approach QR, in my opinion. You don't necessarily want to learn the most efficient way to solve an individual exercise. It's better to learn overarching mindsets and reasoning skills that you can apply to various problems that appear different but can be solved in a similar manner. All right, let's go on to our next exercise. You have 3 minutes. Okay, time is up. Let's see how we can approach this exercise. Okay, so apologies that there's a lot of content here, but let me go step by step. So what we know is that a reading of x corresponds to an impact that is 1/5 of a reading of x plus 1. Right? So when we translate English into math, what we have is 1/5 reading of x plus 1 is equal to a reading of x. So sometimes just translating that English into math and visualizing the question can help you approach this problem in a much more manageable way. And thus we know that a reading of x plus 1 is essentially 5 times greater than a reading of x. And we're being asked, a reading of 12 is how many times greater of a reading of 7? And we can treat that times greater as z. And so the answer choices must represent z. So essentially, we know that a reading of 8 is equal to 5 times a reading of 7, which means that a reading of 9 is equivalent to 5 times a reading of 8. We know that a reading of 8 is 5 times a reading of 7. So a reading of 9 is essentially 25 times a reading of 7, which is essentially 5 squared. And therefore, given the fact that a reading of 10 is 5 times greater than a reading of 9, we know that a reading of 10 must be 5 cubed times a reading of 7. Likewise, a reading of 11 must be equal to 5 to the 4th times a reading of 7. And therefore, a reading of 12 must be 5 to the 5 times a reading of 7. So essentially, reading of 12 is once again 5 to the 5 times a reading of 7, and that is our answer. Answer choice D. So this is how GMAT QR questions could appear as something very complex and difficult, but if you think about what you do know and you don't focus on what you don't know, you'll be surprised about what you can accomplish just by going step by step and taking the time to really try to understand what's going on and not feel the need to produce an explanation really quickly can help you find a creative way and a logical way to solve problems. So it's very easy to see these types of questions and become intimidated. But give yourself a chance by taking a breather, trying to understand what's going on. How can I illustrate this in a mathematical way? Great, let's do one more exercise. Give me 1 second. Give me 1 second, please. I'm looking for a good exercise that we can do. We were going a bit faster than anticipated, but I have another cool exercise for you guys right here. No, not this one. I apologize. Give me 1 second. Here we go. All right, you have 4 minutes to attempt this exercise. Okay, time is up. Let's see how we can approach this exercise. Now, what essentially we're trying to do is compare these terms and order them from greatest to least. The easiest way, in my opinion, to do this is to make the terms as similar as possible. That allows comparisons to be done in a much more intuitive manner. So we could place R, S, and T in terms of 10 to the minus 6. For example, we can manipulate how a term x is expressed. X times 10 to the minus 7 is equivalent to x over 10 to the 7, which is the same when we multiply it by 1. But we can multiply it by 1 in a sophisticated manner to make our lives easier. We can multiply it by 10 squared on top and bottom. It's the same as multiplying it by 1. So we have 10 squared x divided by 10 to the 9. And thus we have 100x times 10 to the minus 9. This is how we can manipulate terms that have scientific notation. Scientific notation is the 10 to a minus exponent, or to any integer exponent. All right, so let's apply this logic to the exercise at hand. Let's express R, S, and T in terms of 10 to the minus 6. R, 65 times 10 to the minus 4 is equivalent to 65 over 10 to the 4th. We multiply by 1 in a way that makes our lives easier, and we want to multiply it by 10 squared on top and bottom. So we have 650 over 10 to the 6, which gives us 650 times 10 to the minus 6. Great. S is, of course, already in terms of 10 to the minus 6. So we have 6,805 times 10 to the minus 6. Now T is 6.35 times 10 to the minus 2, which is equivalent to 6.35 over 10 squared. We multiply by 1 in a way that makes our lives easy. And so we multiply by 10 to the 4th on top and bottom. And we have 63,500 over 10 to the 6th, which gives us 63,500 times 10 to the minus 6. So we have R, S, and T in terms of 10 to the minus 6. And so now we can easily compare them, and we say that T is greater than S, greater than R. C is the correct answer choice. Once again, the overarching mindset that I want from you all is to think of ways to make your lives easy. Regardless of who you approach the GMAT with, whoever you work with to prepare you, or if you do it on your own, you're going to learn different strategies and methodologies. It's important for you to always try to make your life easy on the GMAT. And that way, you will think of which tool to use in a specific moment. Do not go into a problem thinking, this is the math I have to do, this is the strategy I must apply. That's not how I would approach to the GMAT. You should always try to make your life easy. Great, so I really appreciate all of you for joining. If you liked today's session, I would greatly appreciate a review. If you have any questions regarding any problem we went over, please hope you took a note of the ID that's on the left-hand side. You can send me a message. Also, if you leave me a review and let me know that you attended today's session, I'll provide you with a 5% discount code. You have to do it before December 28th. All right. Thank you so much for joining. Have a great rest of the weekend.